So my name is Guerra. Good afternoon to everybody. I'm at the Limburg Research Center here in northern Italy. At Limburg, we have are working a lot on apple. We have a small germplasm collection. We do variety testing, and we have also an own breeding program of apple. And we've been involved in research on new breeding technologies, new ways to make apple breeding more efficient. We are embedded in one of the main apple growing areas of Europe. 6,000 apple growers here around our offices, growing 1 million tons of apples every year. So that's why we are also interested and very glad to participate to this project. And coming back to our variety testing and the reality of apple in the world, in fact, there is a lot of breeding efforts around the world. You see here a map from New Zealand to Japan, China, Europe, United States to Southern America and South Africa. There is really, in my experience, and I've been in the business since more than 20 years, breeding efforts have never been that intense in terms of number of seedlings produced every year, trying to reach the market. And on the right side, you see some of these apple varieties which already reached or almost reached the market, labeled. So this different bicolored, yellow, green, different tasting varieties. So as you see also from this picture, or you may know that apple is grown in many parts of the world. So it's a crop which is quite adapted to different conditions. But of course, it is also affected by the environmental effects, which were explained by the previous speakers on other crops. But as all the agricultural crops, as all the plants, they have an interaction, their genetics on one hand, but on the other hand, there's all, of course, the environment. And most of these breeding institutes and public and private ones have very similar objectives. So because we are also breeding, that's why I'm saying we are looking surely still for high and regular bearing apple varieties, orchards. Then if you come to the fruits, there is, of course, in terms of fruit size and shape, we want it to have be in definite way, but especially it should be ideally also homogeneous, not heterogeneous fruits on our trees. The coloration, especially talking bicolored or red-colored varieties, they should be of high and attractive, especially in changing environments, in warmer getting climates. And then, of course, on the other hand, also we have a lot of pathogens and insects challenging our apple trees. So robustness, resistance against biotic stress, but also abiotic stress like drought or other parameters which are changing nowadays also due to climate change. Last but not least, there's people who will eat these apples. So the internal quality, but also storability and shelf life are important. So these are 6 breeding objectives which are quite common to these many breeding programs around the world. And there are more detailed ones, but just to list these main ones. And the challenge also here for apple in breeding is that you may get some of these results in your specific pedoclimatic conditions, but they might be totally different in another pedoclimatic conditions. But ideally, a breeder is also looking for a variety which is adapted to very different varieties, environments, which is therefore resilient and can be grown and successfully grown in many different climates. So this is why we in looking more into detail on this G by E interaction, so genetics environment interaction, and how have we done that in the last years as an Apple science community by building up this so-called RefPop. It's an acronym for reference population. And as you see in the title, it's the European Apple Reference Collection. So from a previous project that was fruit breedomics, there we genotyped a lot of, the most important apple core collections in Europe. And these were, yes, thousands of different cultivars and accessions which were genotyped. And out of this many data, the colleagues from Wageningen University, Marco Bink at this time, they designed this so-called Apple RefPop, which does not include all the 1,000 different cultivars we had in our collections, because we don't have the space to grow them then and to phenotype them. But it represents the variability of the apple Malus domestica, at least in Europe. And we planted back in 2016 on 6 microclimatic sites in Europe this different, the same collection, the same design. So it is grown from Poland on the top right up to Spain in amongst different climates in northern France, Belgium, Limburg Research Center here in northern Italy, and at Agroscope in Switzerland. And we've been already working on this reference population in the framework of INVITE, which was cited also before by David Rousseau. And we have now also another project, Apple Biome, where we are more looking at the microbiome. But last but not least, we have also PHENET to work on this use case of the Apple RefPop. And I'm gonna explain you now what we are planning to do. Before that, just once again, some numbers. So this Apple reference collection consists of almost 300 accessions and almost 300 progenies from parental combinations, and should represent the cultivated apple and the current European breeding material. We have also some reference cultivars in it, so Gold Delicious, after Fuji, the #1 variety in the world, Gala, and scab-resistant, monogenic scab-resistant variety like CIVG 198 Modi. Planted in spring, and we have 2 to 4 single tree replicates per genotype in these 6 sites. Important also to know, we subdivided these collections on the 6 sites in a management 1, where we do normal agricultural practices, so integrated production, IP management, from fertilization to irrigation and to the rest of pruning and treatments. And we have a management 2, which on some sites is no irrigation, so the influence of no irrigation, or the low input, where we do very little or no fungicide treatment. Very important also to know, this collection is already being fully genotyped. So we have the genetic variome with the 480K Affymetrix. This was done in previous project I mentioned before. So we have a fully genotyped collection on 6 sites. And here you see just some pictures, some examples of the variability in shape, in colors, in fruit size, in tree architecture, shown before also by David Rousseau, of this collection which we have on these sites. This is pictures from Limburg, for sure. These pictures have another, are different if you take them on the other 5 sites. So what we've been doing in 2018, 19, 20, 21, 22, 23, 24, so up to the last season also, we've been doing a lot of traditional manual phenotyping. So very, very laborious measurements in the orchard, and then also after harvest of the fruits out of the orchard, following a common protocol. And so in 7 consecutive years on 5 sites, which is basically 35 environments. We've been doing this laborious phenotyping. And to be honest, already from the beginning, we've been always hoping to get tools to make this much easier, to make this traditional phenotyping high throughput, as it is the title of my presentation. And yeah, so our idea and our hope is that with PHENET, we will be able to have a more efficient and fast-forward phenotyping tool in our hands, which will help us then also to get more deeper in these G by E studies, which we published up to now. Here you have just an example of some very simple, this is the harvest date on the 6 sites from this collection. So as expected, but just to show you, it is not a one-to-one switch from one area to another one, but it is really, the varieties are reacting in a different way to different environments. So there are some varieties which are more resilient and which also in terms of color well on all these different environments, and other ones which are totally different, which a pomologist like me could not even recognize to be this variety if I'm used to see it here in Italy under our climatic conditions. So yeah, here you have the density of a variable, then the mean value and the median value, just to explain this simple but results which we've obtained up to now in this collection. So we've already published with the traditional phenotyping tools several papers. 2 of them are here where we showed this G by E interaction. But as I said, we want to get further on this exploitation of this information and acquire additional information. Apple trees are different from arable crops. As you know, these are perennial crops. And then an apple orchard normally in our area lasts 15 to 25 years. So this collection is now 8 years old. It's not still in his full development. So there is also interest and idea to get further on that. But our resources are limited in terms of human resources. So we are really looking forward to getting tools which help us to make this more efficient. Well, there are already some commercial companies which have tools for fruit counting, for other vision systems available. Here is just an example of some of them. At Limburg Research Center, we have another project, is the Limburg Integrated Digital Orchard, LIDO. And in the past seasons, we've been validating or trying out these computer vision systems, which are here in our alphabetical order, from C-Clair from France, C-Crop Israel, GeoInference from Italy, Green Atlas from Australia, Hectre from the Netherlands, Naturamon from Italy, Optiflux from Belgium, Prospector from Italy, Tevel from Israel, and Vivid Machines from Canada. There are surely much more of them, but these ones are also specialized on Apple or have their tools on Apple. And well, they kind of work not that bad in a monovarietal block. But as David said, first of all, their algorithm is a black box. So you get the result and that's it. And then there are some of them which are more challenging because you have to recalibrate, etc., etc. So we've been looking at that, but we came also to the conclusion that for our purposes, for what I said before, they do not work. Here you see just some pictures of some of them we've tried out. You see there is even Devil on the upper left, which is working with drones, and some of them are on directly on the tractor. Some of them are even work just with your mobile phone running through. So there's a lot going on to being on the market, but not useful for for our purposes at the moment. There are also tools like this HectorOptiflux, where you just look into your bin, and then it gives you already a grading of the fruits and a color grading, which we normally do with the sorting machines in our post-harvest section. Coming to PHENET, this is why we are planning to do a lot of acquisitions with the so-called PHENomobile. So I'm not yet there to bring results today, as the previous speaker was already talking about some preliminary results and information. In our use case, we had some delay in the acquisition of this PHENomobile. So we will do the real acquisitions with this PHENomobile in the next 3 seasons. In the last season, in this 2024 seasons, we just did some acquisitions with handheld cameras or fixed cameras, not with the PHENomobile. What is the PHENomobile? It is something, a device you can add on your tractor, and it is we have a set of sensors, and it will be used in these sites in Agroscope Switzerland, Better Tree Fruit by INRA in Belgium, INRA in France, IRTA in Spain, and Kleinburg Research Center. So 5 of the 6 sites where we have the RefPop, and it is built by HYPHEN, which is a partner of the PHENET project. Here you see a picture and some explanation of how this PHENomobile is built up, especially made for the apple orchards. HYPHEN has been working in arable crops and now is going on to, working also on tree crops like apple. And we just got this device delivered last week, and so it's also we did the first trials in this running week, assembling it. There are 2 RGB cameras, 2 flashes, 1 LiDAR, and the GNSS antennas, which allow us to do to localize what we are acquiring with these cameras. The idea is, you see here on the right, so expected arrival winter 24-25. I'm writing that because it arrived in Switzerland and in Italy here, and it will be delivered to the other colleagues in Belgium and Spain in the next weeks. So we are, our idea is to acquire information on flowering intensity, tree architecture, number of fruits, fruit size, dynamic size, make a monitoring, a dynamic monitoring of the size, acquire also color information on the trees in the orchard, and then a general condition of trees and a general condition of the fruits in terms of its stress condition. So we left that a little bit still open. We might get more precise if we see that there are good pictures and good algorithms we can develop. But the main purpose are the first parameters you see here, where you got already some preliminary information from David, that we don't start from zero. There is already from a previous project some algorithms, some tools available, which we will enrich with our information and with the vast variability of different genotypes and accessions which we have available. And once we will be there, as I said, then we can merge them with the genetic information, which is already there, which is already available, to further exploit the G/E interaction on it. So they are, I think this is already said. It's just a repetition of what I said. Of course, we made some benchmarks. So what is the minimum we want to reach to divide our flowering intensity in 9 classes? Of course, the dream would be to count a single flower. We might get there one day, but at the moment, our minimum benchmark is this. And in terms of number of fruits, of fruit size, etc., you see that we gave us some benchmarks just to say this is the minimum we want to achieve in terms of precision, of reliability. If we get better, and we hope to enforce this also in these 3 years of acquisitions, 25, 26, and 27. So this is a little bit plan our what we are planning to do. So now in winter time, our apples are dormant, no leaves and fruits on them, and that's a good point to got a good timing to do acquisitions on tree architecture. Then we have the flowering starting in March, April, where we do the flowering, and then towards the August, starting from July, there are also some very early varieties in the collection. We will do the acquisitions and then the annotations then if needed of the other traits which I explained to you, and which, if you recall, my first slides are very important for breeders and for selecting new varieties. Finishing that, we also have a dream in our use case, as the other use cases have. So the idea is to substitute the significant number of these manual phenotyping in the orchards with these high throughput methods in order to accelerate the development of smart breeding. So do GWAS use this phenotyping information combined with genetic information to further develop our new breeding technologies, our smart breeding tools, and the crop modeling. This, by the way, I think that there is then also potential that these tools, these algorithms, can then also used by variety testers, normal varieties, by DUS offices, maybe by germplasm curators, and last but not least, why not also by our farmers. Thank you for that, and I'm open for questions.